I want to show that the leading term of a polynomial always dominates. That's a well-known fact. I want to demonstrate with this particular polynomial, then I'll do a general proof. But you would think all of these terms would overwhelm this one. I made large coefficients and everything else go in the opposite direction. If we factor out that negative, then we can see we have the leading term minus all the other terms. And if we enter an x value of 1, then we're in the negative, which would make sense if the other terms are winning. At an x value of 5, same thing. It looks like they're really winning, but when you get to an x value of 101, suddenly it has gone positive and the leading term is winning. And then at an x value of 102, it's really winning. How do we know that's always going to happen? So what we can do is use a rational function, kind of a contest function, and I'm going to make a contest between the leading term and all the other terms, and whichever one grows faster will affect this rational function. If x to the 5 is growing faster, then c will go to 0. If the other terms are growing faster, it'll go to infinity. So if we just do some basic fraction manipulation here, we get to a point where we can see that the denominators are definitely going to grow faster. And so we see as x goes to infinity, c goes to 0, proving that this term is more powerful than all the others at high values of x. Going the other way, just to be thorough, same thing's going to happen as x goes farther and farther to the left. So we enter in negative numbers. It creates some sign changes, in this case an alternating series, but that doesn't change anything because tiny positive numbers or tiny negative numbers are still tiny. They're still approaching 0. And so as negative x approaches negative infinity, c of negative x approaches 0. So we see that for a particular case, for this polynomial, that as larger and larger positive negative numbers are entered into the contest function, it approaches 0, proving that the denominator x to the 5 grows faster than all the other terms combined. Consequently, at some point, it always eventually dominates the polynomial. So thinking of the polynomial again, we've seen this is just a more powerful term, and that's just the power of another degree. It's the power of exponential math. Higher degrees always win. And so as x goes farther and farther to the right or left, the leading term takes over and determines end behavior. Now for a general proof, it's really straightforward. It's just, I'm going to do the same exact thing again, except I'm going to use general notation so that we're proving this for all polynomials. I'm assuming you are comfortable with this notation if you're watching this video. Again, we're just going to make a contest rational function where we put the leading term on the bottom, all the other terms in the top, and we're going to show that this term is more powerful as x's progress to the right or to the left. And so I'll leave it to you to kind of make sense of this. This can be a little confusing, but I think if you studied out a little bit, you can see how I get to here. And again, we have a situation where the bottom is definitely growing. The top is just, these are just all the coefficients of the polynomial. And so as x gets larger, each term goes to 0, driving the function c of x to 0. So as x goes to infinity, c goes to infinity, proving that this term becomes more powerful. And so it is definitely going to dominate. The first term, the highest degree term of a polynomial, is always going to dominate all the other terms. I'll leave it to you if you want to read this, but basically that makes the point. And I find this interesting, and I hope you do too.